So we're working with implicit differentiation, and maybe the most important piece of this entire thing is to realize what our derivative with respect to x of a y function is. And it could be y, it could be t, it could be any other variable that isn't explicitly x. Okay? So here we assume that y is a function of x, and if we have d dx, or the derivative with respect to x, of y to the r power, this is equal to r times y to the r minus 1 times the derivative of y with respect to x. This is going to be key. Okay? So you're just going to want to keep that in mind. This is general power rule with a different function. Hi. In this video we'll be working with implicit differentiation. That's where we're taking derivative of more than one variable now. But all variables, again, will be assumed to be functions. So we're supposed to find dy over dx, the derivative of y with respect to x, if x cubed plus y cubed is equal to x cubed times y cubed. Okay? Well, maybe if you remembered from before, again, if you've remembered from before, what we need to do here is we're going to differentiate this entire equation with respect to x. And really, this thing that we're finding, okay, with respect to x, is going to tell us the derivative that we want to find. So we're looking for dx of the entire equation here, which is x cubed plus y cubed is equal to x cubed times y cubed. Okay? So we're going to differentiate each side of our equation separately. Okay? Well, the derivative with respect to x of x cubed is 3x squared. That one's pretty easy. Okay? Moving on, we have a sum rule. So I'm going to add on to it the derivative with respect to x of y cubed. Again, y we consider a differentiable function of x. And that allows us to say that it's 3 times y squared from general power rule, and then chain rule gives us this all times dy over dx. Okay? That takes care of this side of the equation. Okay? Moving on to our other side of our equation, we now have a product rule, as well as some general power rules to deal with. So, the product rule says that we need to take the derivative of the first times the second, plus the derivative of the second times the first. Let's go through that piece by piece. The derivative of the first is going to be 3x squared times the second, it's going to be y cubed. Okay? Then we plus the derivative of the second of this y cubed times the first. Well, derivative of y cubed is again going to be 3y squared times the derivative of y with respect to x. All of this is times that first, which is x cubed. Okay? So you see that we have very similar pieces here and here, okay? Because we're evaluating y cubed on both of them. The reason it's different over here is because we have that product rule. Okay? So at this point, what we have is a dy dx term here and another dy dx term way over here. What I want to do is group all of my dy dx terms together on one side and then divide out by our common coefficients. Okay? So I'm going to go about that now. I need to move everything else to the other side. So this 3x squared needs to be a minus 3x squared to both sides. And move that, shoot that across. Okay? Likewise, this 3x squared y squared x cubed needs to actually come over to this side. Okay? So I'm going to actually subtract that as well. 3y squared dy over dx x cubed. So I'm subtracting that whole term from both sides. Okay, so this cancels here, and to rewrite, what I now have is 3y squared minus 3y squared x cubed times dy over dx And there's me just reorganizing. Okay, here's my positive 3y squared. Okay, times the dy dx, great. And negative 3y squared x cubed, negative 3y squared x cubed, times dy dx is right there. Okay, so that's that. And this whole thing is equal to 3x squared y cubed minus 3x squared. Okay. So there's that, and now I've almost got dy dx by itself. Right now I just need to divide both sides. This coefficient out here, this 3y squared minus 3y squared x cubed. And as that happens, this reduces to 1, leaving me with dy over dx is equal to, well, let's see over here. I've got 3x squareds up top, but only y squareds in common at the bottom. The only common factor I have between the top and the bottom is a positive 3. And so I'm going to put that out here. There's going to be 3 times x squared y cubed minus x squared divided by y squared minus y squared x cubed, and these 3's reduce down to 1. And so there we have it. We found the derivative of y with respect to x, and it's x squared y cubed minus x squared divided by y squared minus y squared times x cubed.